Well, welcome back. Well, actually, not welcome back. Yeah, welcome back to New Year, New You. We're starting the second part of this quarter today. So what you are learning from today to the end of the quarter will be on your final exam. Or, excuse me, not be on your final exam. Will be on the next exam, and then you will have a midterm. The midterm will cover everything that comes from the first day of school till what we've learned so far. Taking a look at the drill, you should have been able to do these because it was just multiplication. That's what we did before. It was what was on the last test. So 1, 2, and 4 are differences of two squares. And you're probably saying, what does that even mean, Finney? That means when I look at these two, I see x plus 5 and I see x minus 5. The only difference is the sign. So that means when I multiply these out, it's going to drop the middle term. So I would end up with x squared plus 20 or minus 25. Same thing for the next one. I have n plus 1 and n minus 1. The middle terms are going to drop out. I'll end up with n squared minus 1. Number 3 is different, though. Number 3 says p minus 1 quantity squared, which means I'm going to take p minus 1 times p minus 1. The middles don't drop out. They actually double. So I'm going to do p times p is p squared. P times negative 1 is negative 1p. Negative 1 times p is negative 1p, which makes it negative 2p. And then negative 1 and negative 1 is positive 1. So that becomes a perfect square trinomial. And that's what 3, 5, and 6 are. They're all perfect square trinomials. But number 4 is a difference of two squares. Number 5 is a perfect square trinomial. And number 6 is a perfect square trinomial. And if you learned how to do that in Algebra 2 by expanding with a squared plus 2ab plus b squared, you can do that. Or if you want to write it twice in FOIL, that's fine. But our objective today is to learn the vocabulary of functions in order to recognize and graph functions as well as state the domain and range of the function. So that's our overall goal. Now this is review, which is why I've made this video, and a lot of this is very definition and direct instruction heavy, so I thought I would give you the option to watch the video instead of just listening to me talk the whole period, and you might get done a little earlier. So the first thing we need to do is some vocabulary. Terminology-wise, a blank is a set of any ordered pairs. And the answer to that is a relation. A relation is a set of ordered pairs. So anytime you have a set of ordered pairs, that's called a relation. The blank of a relation is the set of all the first components in the ordered pairs, generally the x values. So if you think back to what you learned from Mr. Tucci, Miss Weiland, myself, Mr. Chang, depending on how long you had Algebra 2, Miss Budzinski, we probably told you that when you think about domain, you think about the x values. So the domain are the x values. That's true in a relation and a function, because a function is a specific relation. The second part of a relation is the set of all components of the ordered pairs, the second part of them, which is the y values. That's called our range. So when we talk about range, we're looking at the y values. And lots of times when we look at the graph, we kind of make a window and ask ourselves, where does this graph lie between? Where does this graph lie between for x? Where does this graph lie between for y? And we decide what our domain and range is there. The last thing says it's a specific relation in which each first component corresponds to exactly one second component. The important part there is each first component corresponds to exactly one second component. Each first component corresponds to exactly one second component. Now that sounds kind of odd, but it means that the first component never repeats. It's only paired with one number. The y can repeat, but the x doesn't, and that is an example of a function. So for each of these relations, we want to give the domain and the range, and then answer, is it a function? So our domain, remember we said our domain was the x coordinates. We have 0, 4, 3, and 10. You do not have to list them in order. When you list the domain, you're going to put it in a set, just like we have here. So we have 0, 4, 3, and 10. Our range would be the y coordinates. So our range is the second value. So we have 2, 5, 7, and that's a terrible circle, but you get the drift, and negative 1. Now, I didn't list them in order. If you want to put them in order, you'd put negative 1 first, and it'd be fine. So now the question is this a function? Is each x different? 0, 4, 3, and 10. Each x is different, so this is in fact a function because x does not repeat. If x repeated, it would not be a function. It doesn't matter what y does. It matters what x does. So, domain looking at the x coordinates. Range is looking at the y coordinates. Now if you look at this, you can see that 5 is used as an x and as a y here. That's okay. Are all of the x's different? Since they're all different, then it is a function. Even though that 5 is used as x and y. And even though 5 goes with 5 and 1 goes with 5, it's okay. It's kind of like, I like to think of it like relationships, because it's a relation. And it's okay lots of times for the guy to have more than one girl. They think that's okay. They're called a playa. But if a girl goes with more than one guy at a time, she's a hoe. And I just don't see that that's fair, but that's what society does, and that's what happens here. This 5 is a playa, and that's acceptable, but a hoe is not. So anyway, taking a look at the next set of ordered pairs. Our x coordinates are -3, 0, 5, and 5. Now in this case, 5 is used twice. 5 is partnered with -2 and 6, and since it's partnered with both of those, 5's a hoe. So since 5 repeats, it's not a function. Now I realize that hoe playa thing is not a good analogy, but and it's an okay analogy, but I just don't know that it's an appropriate one. All right, function notation is, as stated below, y equals f of x equals some statement, which means that when you see f of x equals x squared minus 3, and you see y equals x squared minus 3, they mean the same thing. So f of x is really the same as y. If you see g of x, if you see h of x, any of those of x's are the same thing as y. The f parentheses x is read as f of x, or f evaluated at x. Y value is known as the dependent variable, and x is the independent variable. So x is independent and y is dependent. That's why it's f of x, because f is determined by x. Whatever you put in for x is what determines what y is. So let's do some evaluation. Now, lots of times this gets a little complicated, but you're just making it complicated. If you read the first thing there, it says f of x equals 3x minus 4. And they want us to find f of 2. So the first thing we're going to do is we're going to rewrite this, and just like we replaced x here with 2, we're going to replace x here with 2. So 3 times 2 is 6. 6 minus 4 is 2. So that would mean if we wrote this as an ordered pair, it would be the ordered pair 2, 2. Likewise, when we plug in -3, we'd have f of -3, and then 3 times -3 is -9. -9 minus 4 would be -13. So we would have the ordered pair -3, -13. Okay, I'll let you try this one. Once you get to here, folks, you can just type it in your calculator. Use the parentheses, put it in your calculator. Now this one's interesting because it says h of x equals 3, but there's no x in it, which means this is just a horizontal line, because h of x is the same as y equals. Y equals 3 is a horizontal line, so no matter what you plug in for x, your answer is always going to be 3. Now this one gets a little bit more complex. What they want you to do is substitute the variables in and simplify. So we're going to put a in for x. Doesn't change anything except now x is an a. And then we're going to put b plus 1 in for x. So now we're going to distribute that and combine like terms. So that does change things a little, but you just follow the algebra. Notice we distributed our -4, and then we combined like terms. Same thing here. We're going to plug a in, and then we're going to plug c plus 2 in. We're going to distribute the 5 and combine like terms. Now, there is something in mathematics we have to check functions to see if they are in fact graphs and see if they are in fact functions. And it's called a vertical line test. Now, we defined a function as a relation where each x is different, where x does not repeat. So the graph of relation that passes the vertical line test is a function. Why? Well, think about it. If this passes the vertical line test, every x has a different y. Whereas the second graph, if it passes the vertical line test, every x has a different y. And I can see by looking at this that right there, even though my line kept going, there's more than one x. This x at 2.4 has a positive value and a negative value. So this would not be a function. So that's why when we take square roots, we only look at the positive ones so that it can be a function. So take a look at these two graphs. Which one's going to be the function? Right, the one on the right would be the function, because the one on the left is a circle and it's not going to pass the vertical line test. Now I brought the line over farther, but you don't have to take it that far. And again, the one that's the absolute value function is in fact a function because it only passes one at a time. The lights just came back on. I'm thinking there might be a mouse in here. Interesting. Interesting. All right, domains of functions. The domain of the function is the set of all values for which the function is defined. Generally, what we're doing is we're looking for a situation when we're trying to find the domain of a function where the denominator could be equal to 0, because you can't divide by 0, or you have a negative number with an even radical. So you can't take the square root of a negative number. So those are the restrictions. So for instance, if we ask you to find the domain of this, you always start saying they're all real numbers. When I look at this, it's not all real numbers. How do I know it's not all real numbers? It has a denominator. That denominator is x minus 2. So in order to find the restrictions, what I'm going to do is find a restriction. It's going to be all real numbers except. What's my exception? Well, my exception is when x minus 2 is 0, because x minus 2 can't be 0. The denominator can't be 0. We can't divide by it. So we solve that equation, and so x is 2. So that means my domain would be all real numbers except 2. Because if I put a 2 in there, I have 4 divided by 2 minus 2, which is 4 divided by 0, which is undefined. The world blows up. What if we have a radical symbol? Well, this is a square root, which means when we take the square root, we can't take the square root of a negative number. So this under here, this 3x minus 2, has to be positive. What does it mean to be positive? Yes, it means to be happy. Yes, it means you see the sunshine. Yes, it means you're the happy-go-lucky gal. You're going to simplify that, and you want to find when is 3x minus 2 greater than or equal to 0. Now, why can it be 0? Because you can take the square root of 0. So we solve this. And we find that as long as x is greater than or equal to 2/3, we're good. Because if I put in 0 here, 3 times 0 is negative 2, or 3 times 0 is 0, minus 2 is negative 2, that doesn't work. I can't take the square root of negative 2. So our answer would be all real numbers greater than or equal to 2/3. So you try one. This actually combines both rules, right? So we said this time it has to be greater than 0. Why can't it equal 0? Because it's in the denominator. So you solve that little equation, and that tells you what your domain is. It's all real numbers greater than negative 4/7. Now find the domain of each function here. Is there a denominator? No. Is there a radical? No. If I graphed it, I'd be good. So there's no apparent restrictions, so we would say that this has all real numbers. Now, if you're going to graph a function, the easiest way to graph a function is go to your calculator, put it in y equals, make a table, plot them. So I plot 2x plus 1 in my calculator, plug in -1, I get -1. Plug in 0, I get 1. Plug in 1, I get 3. Plug in 2, I get 5. And I plot those points. So this is the graph of a line. What's the domain? Well, doesn't seem to be any restrictions. There's no denominator. There's no square roots. So it's all real numbers. Check this one out. Okay, check your graph using the graphing calculator. Where we're going to go to y equals, we're going to type this in. X squared minus 3. We go to the table. -2 squared is 4. 4 minus 3 is 1. -1 squared is 1. 1 minus 3 is -2. 0 squared is 0 minus 3 is negative 3. 1 squared is 1 minus 3 is negative 2. 2 squared is 4 minus 3 is 1. And we plot our points. Same thing here. Go to the calculator, type it in. Now, notice these numbers that I chose here? I chose them because the y values would be whole numbers, so that when I graphed it, I wouldn't have to worry about plotting a decimal. You can do that. If you're using your calculator, go to your table and pick the values that have whole numbers. It makes it easier to plot. What's our domain here? Well, it's true that what's in our domain has to be greater than 0, or what's in our square root has to be greater than 0. So that means we would have x minus 1 has to be greater than or equal to 0. True? So that means that x has to be greater than or equal to 1. Because that's where we start. We can't put a negative number in there. We can't put 0 in there. And our range would be greater than 1. Y is greater than 0. Why? Because everything we get is greater than or equal to 0. Absolute value, you can take absolute values. The absolute value of negative 2 is 2. 2 plus 3 is 5. How do you put absolute value in your calculator? You do math, you arrow over to num, and it's ABS. And then you plot your points. What's our domain here? Our domain is all reals. What's our range? There's nothing lower than 3. So our range would be y is greater than or equal to 3, because there's nothing less than 3 in that range. Now it says here your function homework is available on my math lab until December 22nd, and that is false. I believe that it is available on my math lab until January 14th, which happens to be my anniversary. So you can do my math lab homework on there until January 14th. Hey, thanks for coming out.